Evidence for water on Mars first came to light in the year 2000, with the appearance of gillies that suggest a liquid origin. Their formation has been hotly debated over the ensuing years. Observation of the red planet indicate that rivers and oceans may have been prominent features in this early history. But the planet is smaller than the Earth, with less gravity and thinner atmosphere. Over the time, as liquid water evaporated, more and more of it escaped into space, allowing less to fall back to the surface of the planet. But where is the water today? First identified in 2000, features known as recurrent slope line (RSL) were confirmed to be signs of salty water running on the surface of the planet today. The dark streaks appear seasonally on Martian slopes were found in images taken by the high-resolution imaging science experiment camera aboard the Mars Reconnaissance Orbiter. Spectral analysis of RSL leads scientists to conclude that they are caused by salty liquid water, which, according to the study's lead author, Yujendra Oha, the detection of hydrated salts of these slopes means that water plays a vital role in the formation of these streaks. Vast deposits of water appear to be trapped within the ice caps at the north and south poles of the planet. Each summer, as temperature increases, the caps shrink slightly as their content skips strikes from solid to gas form. But in the winter, cooler temperatures cause them to grow to latitudes as low as 45 degrees, or halfway to the equator. Frozen water also lies beneath the surface. Scientists discovered a slab of ice as large as California and Texas combined in the region between the equator and north pole of the red planet.
When Mariner 9 became first craft to orbit another planet in 1971, the photographs it returned of dry river beds and canyons seemed to indicate that water had once existed on the Martian surface. Images from the Viking orbiters only strengthened the idea that many of the landforms may have been created by running water. Data from the Viking landers pointed to the presence of water beneath the surface, but the experiments were deemed inconclusive. Impact craters offer a view of the interior of the red planet. Using the ESA's Mars Express and NASA's Mars Reconnaissance Orbiter, scientists were able to study rocks ejected from the planet's interior, finding minerals that suggested the presence of water. The probes dug into the ground, examining rocks and performing experiments. In 2008, Phoenix turned up small chunks of bright material that disappeared after 4 days, leading scientists to surmise that they were pieces of water ice. The lander went on to detect water vapor in a sample it collected and analyzed, confirming the presence of frozen water on the red planet.
Liquid gold water may seem like a very common element to those of us stuck on Earth, but it has a great value. In addition to understanding how Mars may have changed and developed over time, scientists hope that finding water will help them to find something even more valuable: life, either past or present. Only Earth is known to host life, and life on our planet requires water. So life could conceivably evolve without relying on this precious liquid. Scientists can only work with what they know. Thus they hope that locating water on celestial bodies such as Mars will lead to finding evidence for life. With this in mind, NASA developed a strategy for exploring the red planet that takes as its mantra, "Follow the water." Recent orbiters, landers, and rovers sent to Mars were designed to search for water, rather than life, in the hopes of finding environments where life could have thrived. That has changed, however, with the flood of evidence these robots have returned. Curiosity determined that Mars could indeed have supported microbial life in the ancient past, and the next NASA rover, a car-sized robot based heavily on Curiosity's basic design, will blast off in 2020 to look for evidence of past red planet life.